Alright, welcome to the second video for section 3.1. I wanted to have a separate video in which I showed you how to find the mean of a frequency table. And so I typed out a frequency table up top that we can work with, and the whole goal was to find the mean. So there's some problems when data is given to you in frequency tables. The most common mistake is for somebody to just work with the frequencies, but the frequencies aren't the data, they're the count of the data. So what do we know? As I read this frequency table, I know that there's 15 values that are either 0, 1, or 2. I don't know what they are. All 15 of them could be 0. Some of them could be 0, some of them could be 1, some of them could be 2. That's pretty likely. All 15 could be 2 or 1. And so we don't know. So we actually don't know what the data is. We just know there's 15 of them. There's 14 numbers that are either 3, 4, or 5. And there's 3 numbers that are either 6, 7, or 8, and so forth and so on. Well, we know that if we're going to find the mean, what I need to do is add up the data and divide by n, but I'm at a disadvantage because I don't know what that data is. And so here's what we do. I'm going to take a moment just to rewrite that frequency table. The 0 to 2, the 3 to 5, the 6 to 8, the 9 to 11, and the 12 to 14. And then I'm going to put the frequency in as well. And the frequency that was given was 15, 14, 3, 2, 1. Now, why do this? Why recopy what's up there? Well, here's the reason. We need to talk, and I need to be able to write right here. So these first 15 values, here's what we know. There's 15, 29, 30, there's 35 values it looks like. Does that make sense? 15, 29, as I get to the next one, 31, 30, I'm sorry, 29, 32, 34, 35. Yeah, there's 35 pieces of data. And so I know what to do. I need to, in order to find the mean, I better sum up something and divide by 35 because that's the total number of data points. So as we go to find a formula for the frequency table, it's still going to have this same n in there. So that's going to be locked into stone. Now let's talk about what we do. We have no idea what these 15 values really are, but we do know where they're bound. So what do? Well, I go right in the middle. And I'm going to put an x up here. Now x represents a data value, and just for emphasis I'm going to come in here in a different color. I'm going to put a 1. Now what is 1? 1 is the midpoint of that first class. So this right here is the midpoint. So I don't know how many zeros, ones, or twos I have, so I'm going to go right in the middle and assume all 15 values are 1. I'll be too high sometimes and too low other times and right on other times. We're doing the best that we can. We're going right into the middle. Between 3 and 5 is the number 4. Between 6 and 8 is the number 7. Plus 3 is 10. Plus 3 is 13. Those are my midpoints. And what I'm essentially going to do is assume that the first 15 points are all 1. That my data set looks like this. 15 times. Right? Let me put a 15 up here. And then my next ones are all going to be 4s. How many are my next ones? Well, there's 14 of these guys. Then the next 3 numbers are 7, followed by a couple 10s, and lastly a 13. That's the data set I'm assuming that I have. And so what would we do? If we knew that this was our data set that's down here in red, I would simply add up all these things, right? I'd add the 15 ones, the 14 fours, the 3 sevens, and the 10s. And I can add 15 ones pretty quickly by taking 15 times 1. And 14 fours, 14 times 4. And 3 sevens, 3 times 7. And 2 10s, 2 times 10. And 1 13, 1 times 13. And then I would just simply add those. So what do? We have to add on a new column. I'll go back to blue. Oops. And do an f times x column. And remember what the f times x is doing. I wanted to show it to you. It is doing these partial sums. So we're going to assume all 15 values are 1, and the total of that is 15. Then we're going to assume the next 14 values are 4. And what's 4 added up 14 times? I believe it's 56. I'll double check that. Right, use your calculator. You can use it. 3 sevens, well, I know that's 21. 2 tens, I know that's 20. And 1 13, well, that's 13. So what do I have to do in order to get my result? I have to add up all of the f times x's and divide that by the sample size. So the formula is f times x divided by n. That's the formula that you're going to use. You're welcome to write that down and bring it with you the day of the exam because it's that nice. So what's x bar? It is the sum of the f times x's. It's the 15 plus the 56 plus the 21 plus the 20 plus the 13 for 125. Right? That's what this column totals, that very last one. And then how many, what's my number underneath? So many times, and I'll put it in red. The issue is when somebody puts a 5 in here. And they'll say, well, Jensen, it's got to be a 5 because I added up 5 numbers. No, you didn't. You think you did, but you added up 5 partial sums representing 35 numbers. So this is not a 5 under there. It is a 35. And all we have to do is take 125 and divide by 35, and we're going to get our answer. It's looking like 3.571. Our data was all in whole numbers, so they're asking us to report it as 3.6 as the mean of that frequency table. So pretty good. You'll have some opportunity to practice with that in the homework, so give it a shot and see how it goes. It is the most challenging part of the section, but still manageable if you understand the underlying idea, or just follow the formula. The formula is telling you exactly what to do, and that formula, I think, well, it's printed in the book right before the problem set, but I'm not sure how that comes across online. So let me know of struggles that you're having with this or anything else. Thanks so much.